Welcome to EDU World Space.
Here's problem 23.24. Crystals of hydrated chromium 3 chlorides are green color. So it is green. And have an empirical formula of CrCl3 times 6 water. And they're highly soluble. Question A is asking you to write the complex ion that exists in the compound. So I have searched some reference from the internet. When the color is showing green, they have this formula, and the solution will look like this color. There are other two possibilities, the purple and the blue-green. That is not our case. So for the green color, we have the complex formula written as CrH2O 4Cl2 Cl times 2 water. So this is the complex formula, but we need to look for the ion. So we know that the ligands which are attached to the metal through primary valence are ionizable. So this is ionizable. And those ligands which are attached through the secondary valence are non-ionizable. So this is non-ionizable. So the ionization of this compound in aqueous solution can be shown as here. The equation would be CrH2O 4Cl2 Cl times 2 water. This is water solution. And after the aqueous medium, we get chloride and CrH2O4 Cl2 positive. So the complex ion that is formed by this compound will be this one. This is the complex ion we get for question A. Alright, now question B is saying if the complex is treated with excess of silver nitrate solution, how many moles of silver chloride will precipitate per moles of this solution? So when the complex is treated with silver nitrate solution, for each mole of this complex, 1 mole of silver nitrate is required. This is because the chromium H2O4 Cl2 Cl after the ionization we get CrH2O4 Cl2 plus and 1 chloride ion. So 1 mole of chloride ion that satisfies the primary valence of the complex. And this means that only 1 chloride atoms that can be ionized in aqueous solution. So each mole of this complex have 1 mole of chloride ion, and 1 mole of chloride ion will react with silver nitrate solution and giving 1 mole of the white precipitate and NO3 negative. So the answer for the part B is 1 mole. All right, now move to the last part. Part C says crystals of anhydrous chromium chlorides are violet and insoluble in aqueous solution. The coordination geometry of chromium in these crystals is tetrahedral. So here we have the tetrahedral structure of CrCl3 right here. So the coordination geometry of this chromium are octahedral. So each chromium is right here. The gray color is chromium, and the green color are the chloride. So as it almost always the case for chromium 3+, how can this be the case for ratio of chromium to chloride 1:6? All right, to answer this question, we have in the case of anhydrous chromium chloride, CrCl3, each chromium ion is attached to 3 chloride ions. So the ratio looks like it's 1:3. However, the structure of this is octahedral. And octahedral means that each chromium will be attaching to 6 chloride ions. And why is that different? This is because all these chloride ions, all of them, this ion's chloride is shared. So the chloride ion is shared by 2 chromium ions. For example, this one is shared by this chromium and the other chromium. So that means each of this chloride will be shared in half. And that is why the octahedral geometry look like this. And that is why the formula will be ClCl3.